Well, here we have one diagram, 6 exercises. I'm given a red angle here, right there, that's BAC, 53 degrees, and this segment, just DE, is 8. Let's get to it. We've got 6. Go for the angles first. Well, this is 53, so is this, because the diagonals of the rhombus are angle bisectors. Oh yeah, that's good. How about AED? Well, diagonals are perpendicular for a rhombus, and that means it's 90. Now, I could go many different ways to get the next one. I could use triangles, but let's stick to our properties of parallelograms. And right here I've got 106 for the angle, for this angle, for angle BAD, and that means that its adjacent or consecutive angle must be 74. That would be the supplement of 106. So, easily done. Now, let's move on to the segment lengths. Well, if this is 8, then the whole diagonal must be 16. This is simply a property of parallelograms. Diagonals bisect each other. Nicely done. Now it's trig time, the moment you've been waiting for. Because I know this is 8. I need to find this, and I've got a 53-degree angle. Opposite over adjacent. Come on, it wasn't that long ago. TOA, SOHCAHTOA, TOA, that's obviously tangent. So the tangent of 53 equals 8 over x. And we're going to rearrange, that's our algebra, and we'll pull up the calculator if you really want to see it. We'll be fast here. 8 divided by, there's 53, there's my tangent in degrees, equals, and about 6, to the nearest tenth, 6.0. If I double it, I'm going to get 12. Keep an eye on that. So, that's going to tell me that it's about 6. So this side AE, that's number 36, is about 6.0, and that means that the other diagonal AC must be about 12 and 0/10. So that's good. 6 exercises, no problem. Another diagram with 6 more exercises. Let's get started. Angle SRT. Where is that angle SRT? Well, it's up here. And I could find it 2 ways. I could use the triangle sum theorem of this triangle, or I could just say it's the complement of this 34-degree angle right there. Either way, it's 56. Now, let's hang on to that thought there. Let me put a 34-degree angle there. Why? Because, well, I've got an isosceles triangle right here. What isosceles triangle, you say? I'm talking about this isosceles triangle right there. Well, 34 and 34, that means that the remaining angle must be 112. That would be your answer for angle QPR. QPR and number 39. Whew, getting out of hand here. So QP, let's look at that. Well, these diagonals bisect each other, so that's going to be your 5 right there for QP. That's number 40. Now, how about RP? Well, RP is the same thing. If I've got 5 here, I just said it's isosceles. See, base angles are congruent. 5 and 5. So 40 and 41 are both 5. Remember, we split this diagonal in half there. Now, we're down to trig. The last 2 are trig. And we've got to pay attention to which triangles we're looking at. For 42, I'm solving for QR. I'm going to use the variable K for QR. And we're going to need, right here, this triangle. Ay, caramba. If I use this, this big triangle, and I've got an angle here, I've got 34. I'm going to have an adjacent over a hypotenuse, or if I use the sine of the other angle. Hope I wrote it right here. Maybe and let me see what I got here. the cosine of 34 degrees. Again, this triangle, the adjacent over the hypotenuse, the other diagonal must also be 10 in a rectangle. That's the setup, and I'll shuffle it around. K is 10 times the cosine of 34. You're on your own for the calculator. You've got to do that by now. And let's see. We've got one more side to find, and I call that H. That's number 43, RS. Let's use this triangle now. And you see I could use my angle 34 down here, use sine, or I could use the 56 and cosine. But I always like to use the angle I'm given. The given angle is the 34. So let's go with that. From here, this triangle, the sine of 34 degrees is H over the other diagonal 10. Rearrange, and H is 10 times the sine of 34. So there you have it. One more diagram, 6 more exercises. Well, you won't need any trig here. I've just got a square, and this piece of the diagonal is 1. So let's answer these 6 questions. 44. Well, that looks pretty obvious. I've got a 90-degree angle right here at MKN. 90 here, 90 here, 90 here. I've got a pair of perpendicular diagonals. Easy. 45, LMK. Well, we know that the diagonals are all angle bisectors as well. As a matter of fact, we've got 45 degrees everywhere here. 45, 45. And as far as question number 46, which was LPK, 45 degrees there as well. So you see we have 45, 45, 90 triangles everywhere. That's going to come in handy on the last one. KN, well, let's see. KN must, if LK is 1, KN is also 1. And the opposite diagonal must be, well, congruent. So this one must be 2. Whoops. And when I say that, that's MP, is that opposite diagonal. Now LP itself, finally a side. Let's look at this as a 45, 45, 90 triangle. Ratio of the sides, 1, 1, and yes, you remember, radical 2. So, easy.